Hi, my name is Scott and here's my solution for assignment 1, the stopwatch. First of all, the step stop button controls the clock of the D flip-flop to change the output. So I use a simple logic circuit to combine the reset button, which only controls the timer stop. I only have 5 minutes, so I will jump into the main circuit. So the main circuit is divided into two parts, which is elapsed time and sleep time. So for the elapsed time, I built two components. One counts from 0 to 9 and the other counts from 0 to 6. So for the stage 2, components can count from 0 to 9 and the stage 3 components count from 0 to 6. In this layout, I use 5 AND gates, 1 OR gate and 4 JK flip-flop, 1 clock and 1 hash digital display. So basically the idea is to create a 3-bit counter that counts to 0, then combine it with another flip-flop and control input gate to complete the desired outcome. So the stage 1 outputs of the D flip-flop is paired with the clock using AND gate. This is to ensure that the counter works only when the stack signal on. The AND gate used after each JK flip-flop expansion for as triggers later bits to activate when the less significant ones complete their cycles. So similarly for the 0 to 6 counter, I changed the range to count from 0 to 6 using the same logic. So stage 4, so minute display implementation is straightforward since all the hardware has been done in stage 2. Uses the same 0 to 9 counter in stage 2 and connect AND gate in stage 3 with the stage 3. So for the reset button, I connect all the OR gates of the flip-flop deploying to the same button which was provided in the main circuit. For the stage 5, I tried something strict approach, which is to combine 4 4-bit counters where each one is responsible for splitting each display position from 1 to 4. So each carrying bit is connected to the corresponding D input of the D flip-flop and can only be splitted once the split button is activated, where all the clock inputs of the flip-flop are wired to the same button. So the carry out bits are connected to the splitter, which flows to the corresponding digital display in the main circuit. So step 6, this implementation is also straightforward as well. I try with 5 16-bit counters which I deploy in the previous stage 5. So the logics remain the same. Here I use a SAW gate. When I press stop, this will store in this space. That's why I connected the output of the SAW gate to the split button of the each stage 5. So let's start the stopwatch. Okay, when I start the timer, the clock begins. So when I stop the timer, that means like this text stop button works correctly. So when I press the reset button, everything's go back to 0. So when I press the split button, so let's start again. When I press the split button, see the facts, 26 seconds recorded. Pressing it again moves the 26 seconds into the second position and new value is stored in the fax position. See 53. So each press update the split values accordingly and the pressing reset back all the value back to 0.